Most mainstream languages have both while loops and do-while loops. Here you can see the Java syntax for while loops with an example that counts from 1 up to but not including 11. And down here you can see the do-while syntax where the example behaves exactly the same. In general, the difference is that in the do-while loop, the body is executed at least once. But again, in this specific example, it doesn't make a difference. So the question arises, are there any cases where choosing the do-while loop is somehow more natural, leads to shorter code, more idiomatic code, more beautiful code? That's the topic of today's video. We're going to look at 3 specific examples. Okay, let's start with the first example. Here we have a good old for loop that starts the loop counter at the integer min value and increments it up to and including the integer max value. And every time we detect that negating I has no effect on I, we print that I is its own negative. Okay, so what happens here is that integer min value is its own negative, 0 is its own negative, and apparently we're stuck in an infinite loop. So the loop will never terminate on its own, so we have to do it ourselves. Okay, so why is this an infinite loop? That's simply because this loop condition is always true, because every integer is smaller than or equal to the max value. The fact that this increment overflowed cannot be detected after the fact in this condition. Okay, so a very beautiful solution can be achieved with the do-while loop. So let's start at some value, then the increment we do at the end of the loop, and then here we write a do, and then while I hasn't reached the value that we started with, like this. And that now should work correctly. So it again detects these 2 anomalies, and after 4 billion loop iterations, the loop will terminate, okay? Because we're back at the value that we started with. And of course, we can't replace this with a while loop. I can, of course, try. So let me take this, write it up here. And if we now execute this guy, the loop immediately terminates. Because if we start at min value and say as long as we're not back at min value, we want to do something, well, I has, of course, the value that we started with before we incremented it. So this doesn't work, right? So, of course, we have to increment I first before we can do anything useful. Okay, and it's also no good to say, well, so let's start by incrementing I and not doing it here. Then we will miss the first interesting case. We can see that integer min value is no longer detected because we immediately skipped it before we did the check and the relevant code. So this is, I think, really a useful example. The semicolon is missing. To iterate over the complete range of integers. When do you need that? I sometimes use that idiom when I want to exhaustively test simple functions that take one int, and I somehow can test that in a useful manner. Okay, let's continue with the second example. Here we have a vector of the numbers 1, 2, and 3 in sorted order. And the goal of the program is to print out all 6 possible permutations of those numbers. Fortunately, C++ already provides an algorithm called next permutation in the standard library. We pass to it all the numbers in our vector, and it will scramble those numbers in place to go to the next permutation. For example, in the first call to next permutations, those 2 numbers will be swapped. Okay, why can we use next permutation as a loop condition? That's because next permutation will return true most of the time. It will only return false when the permutation after the call is completely sorted. So then we are back at the start, basically. Okay, so what happens if we execute this? Unfortunately, we only see 5 permutations. The first one isn't shown on the terminal, and that's because, well, we started with the initial permutation and then immediately went on to the next permutation before we printed it to the terminal. So a quick fix would be to say, let's simply copy the loop body above the while loop. We also want to see the first permutation, and that indeed works. But of course, you don't really want to do that, right? Especially for more complicated loops or loop bodies. So every time you say, well, first I want to execute the loop body and then I want to check the condition, that's screaming do while loop in our faces. So let's replace the while with a do and paste the while down here. And that should give us the same exact effect without the ugly code duplication. Okay. In some sense, this is similar to the example before. We have an initial value, we do something with it, we go to the next value and then check that we haven't reached the first value yet. And indeed, I have used this exact example multiple times. Every time I want to see all the permutations of some range in C++, this is exactly the idiom that you're supposed to use. Last but not least, my favorite example. Here we see a function that converts an int to a string. It does so by allocating a character array and then filling it, starting at the right, going to the left, isolating the rightmost digit and cutting off the rightmost digit. So the details aren't really that interesting or so important in this video. And we do that. We generate digit after digit until we hit 0, and then we stop. And then we return a new string with those characters that we generated. And you can see the first test case works beautifully. The last test case works beautifully. But somehow the 0 is never printed. Why is that the case? Well, if we replace x with 0, place it here in our loop condition, 0 bigger than 0 is not the case. So we never execute this code, right? So we return an empty string basically. Okay. We could fix this with a special case. We could say if x has the value 0, then return the string consisting of the digit 0, and then everything works. But of course, this is a special case, and maybe we can find a simpler solution. Okay, so basically, this loop body always generates one digit per iteration. And if we want at least one digit in the output, then we want to execute the loop body at least once. And that's exactly how the do-while loop is defined, right? The do-while loop is executed at least once. So if we replace the while loop with a do-while loop, then we should get the desired result without any special cases, right? So you can execute this code in your head. It will do the right thing. And we got rid of the special case. And what I find interesting about this, if you peek into the standard library of your favorite programming languages and have some function that converts it into a string, it has to do something like this, right? So either it has a special case with a 0 or it has a do-while loop. And how often do you see numbers on your computer screen? All the time, right? So I would argue that this is probably the most popular and most important example of a do-while loop. Every time you see a number on your screen, your computer probably executed a do-while loop, and somehow that brings a smile to my face.